This is part 5 of section R.8, nth roots and rational exponents. So in the last video, we found the quantity we needed to multiply by to rationalize the denominator, but we didn't actually do any rationalizing denominators. That's what we're going to do an example for. So, as we saw in the previous example, it said, what would you multiply by if your denominator was the square root of 3? And if you look back at our table, we said we'd multiply by the square root of 3. But of course, we have to multiply the top and the bottom by the same quantity so that we're actually just multiplying by 1. So when we do this, we get 1 times the square root of 3 is the square root of 3. The square root of 3 times the square root of 3 is the square root of 9, which is, I'll write that, but of course we know 3. So we have rationalized the denominator. There's still a radical left in our numerator, but not in the denominator. Okay, let's look at part B here. Now here we have a radical over the whole fraction. The best thing to do here would be to start by breaking it up using one of our properties that says that we can do this. Okay, and now we know what our denominator is, so what do you think we multiply the top and the bottom by in order to get rid of this radical in the denominator? The square root of 2r, correct. Square root of 2r over the square root of 2r. Because the square root of 2r times the square root of 2r will be the square root of 2r squared, which is just 2r. Okay. So in the top, now let's just pull all this together because this is what we know. We know this is all the square root of 5 times 2, I'm putting the two numbers together, times p times q to the 4th times r. That's the entire numerator. And the denominator is just the square root of 2r times the square root of 2r. Let's just write that. 2 times 2 is 4. R times r is r squared. But of course, that will simplify with no radical because that's a perfect square now. So in the top, we have the square root of 10, which has no perfect factors. 5 times 2 is 10, no perfect square factors. P has no perfect square factors. Q to the 4th is a perfect square, so that one's going to come out in R. So let's take the square root of Q to the 4th, and we get Q squared times the square root of 10 times P times R all over. Square root of 4 is 2. The square root of r squared is r. And now we have our simplified answer. Okay, C also has variables and under the radical, but notice this time we have cube root. So we are looking for a way to make that a perfect cube in the denominator. So what, we know 9, what are our perfect cubes? Of course, 2 cubed we said was 8, and 3 cubed is 27. I'm trying to think of a number that 9 might be a multiple of, and I know it's a multiple of 27, and in fact, if I multiply 9 by 3, it will be 27. B squared isn't a perfect cube. If I had one more b, it would be, so I'm going to multiply the top and the bottom by 3. 3 times 9 will give me that 27, and a b. That extra b will make that a b cubed, which will be a perfect cube. Okay, so what do we have in the top? We have 6, oh, these are cube roots, sorry, times the cube root of 3b, that's in the top. In the bottom, we have the cube root. 9 times 3 is 27, b squared times b is b cubed. Both are perfect cubes. So we have 6 cube root of 3b over the cube root of 27, we saw is 3. The cube root of b cubed is b. And I would be done, except I'm noticing that 3 will divide into 6 very nicely. So I'll do that. 3 into 6 leaves 2 cube roots of 3b all over b. Okay. And now we have one that we had an example in the table on the previous video that had a denominator that was a binomial like this, 2 terms. And so look back, what did we say we would multiply the top and the bottom by? we said we'd multiply by the conjugate of this. And the conjugate looks just like this, only we changed the sign between. So we're going to multiply the top and the bottom by 7 minus 2 square roots of 3. 7 minus 2 square roots of 3. This is legal because that's just the number 1. So we have 2 terms here, 2 here. We're going to FOIL the numerator, FOIL the denominator. First times first, 7 times 4 is 28. On the outside, I'll get negative 8 square roots of 3. On the inside times the inside, I'll get negative 7 square roots of 3. Last times last, they're both negative. That makes a positive. 2 times the square root of 3 squared. There's the square root of 3 times square root of 3. All right, in the bottom, if you recall what happens here, there'll be no middle term, because we have a positive and a negative, and it will just end up being 7 squared minus 2 square roots of 3 squared. And the reason this works is there'll be no radical now, because the only radical we have is going to get squared. Okay, so in the top we have 28 minus 15 square roots of 3, negative 8 and negative 7, and then we have plus 2 times the square root of 3 squared. Well, that's going to be the square root of 9, which of course is 3. All over 7 squared is 49 minus 2 squared. Now here the 2 is getting squared, so that's 4 times the square root of 3 squared is 3. Okay, so remember, multiplication comes before addition. Let's simplify. 28 minus 15 square roots of 3 plus 6 over 49 minus 12. So in the top, the 28 and the 6 can come together to give us 34 minus 15 square roots of 3 all over 49 minus 12, which is what? 37. And we're done. There's nothing else we can do with that one. We've completely simplified. Okay, we will continue with the next example in the next video.